Hello, algebra peeps. Okay, so yesterday you watched a video and you talked about what to do when you had a negative exponent. So just a quick reminder on what you would do is if you had 3 to the negative 2 power, we're not allowed to have negative exponents, so we would just move it downstairs and then make it positive. Or if the negative exponent was already downstairs, you would keep what was positive, that has a positive exponent of 1, and then you would have 2 to the 4th that you would bring upstairs. So we just talked about how if you have a negative exponent, it gets voted off the island. If it's upstairs, it goes downstairs. If it's downstairs, it goes upstairs, okay? So today we're going to talk about 3 other exponent rules. And let me level with you guys, okay? I don't expect you to be experts at this. I just want to show you these rules. Hopefully the patterns will make a lot of sense. And we'll kind of refer back to them occasionally. But I don't want anybody to feel like that they have to be an expert on the content in this video, because you do not. All right? So here we go. Rule number 1 that we're going to talk about today is the product rule. And anytime you hear the word product in a math class, you should be thinking about multiplication, okay? So if I look in this table here, we are multiplying the same base. So some of the observations that I need you to make. Do you notice how I have in each one of these problems, I am multiplying, that dot means multiply, the same base, okay? So we're going to see what it looks like if I'm multiplying bases together. And we're going to put this in expanded form. We're going to write it all out to see if we can observe the pattern. And you know what, friends? We are not even going to worry about standard form. We're just not even going to do that. Okay, so here we go. Expanded form for the first one. 2 cubed means 2 times 2 times 2. And now I have the 2 squared. I have this piece, so that would be times 2 squared, which is 2 times 2. So this was 2 cubed. And now that's times 2 squared. So then how many factors of 2 do I have? I have 5. So I'm going to just put 2 to the 5th right there. I'll walk you through the next one, okay? We had 3 to the 4th. So 3 to the 4th is 4 factors of 3. 1, 2, 3, 4. And I got to multiply that by 3 squared. So times 3 times 3. And then if I count all of the factors of 3 that I have multiplied together, there are 6. Okay, so here's what I want you to do. I want you to pause the video. I want you to just fill out the rest of this table. You just jot it down on a piece of paper. And then we're going to come back and talk about the rule form when you are ready to unpause. Okay, now that you've had an opportunity to work through these problems, let's talk about the rule form. So one of the things that we like to do as mathematicians is we want to think smarter and not harder. We don't want to write problems like this in expanded form. That takes a lot of time. So mathematicians are always looking for the shortcut. And so hopefully maybe you noticed that every time you were multiplying all of these, let's see, like right here we had 3 factors of 2 and then 2 factors of 2 for a total of 5 factors of 2. Or right here we had 4 factors of 3. And then we had 2 more factors of 3 for a total of 6 factors of 3. So what's the shortcut? The shortcut is that we're just adding the exponents together. I had a base of 2. Whoops, that's not a pen. I had a base of 2. And then I could have just added the exponents of 3 plus 2, which gave me that exponent of 5. Or here, I could have just done 3 to the 4 plus 2. That gives me 3 to the 6. Again, 5 to the 1 plus 3 would give me 5 to the 4th. 4 squared to the 3rd, or plus 3 would give me 4 to the 5th. And that rule holds out for every single one of these problems. So the pattern, if you wrote it out below, we can write it out now, or we will in just a minute actually. On the next slide, I'll write it out for you. But when we have the same bases, so that only works if we have the same bases. If we have the same bases that are being multiplied together, you would add your exponents. So, the actual product rule definition. The product, again, makes us think of multiplication. And the rule says this: when you are multiplying by the same base, so again, the bases have to be the same, you add the exponents. So when we are multiplying the same base, we would add the exponents. So now we're going to look at some practice, okay? So here, 5 squared times 5 to the 4th. You would do 5 to the 2 plus 4. Those are the same base. You're just going to add the exponents. So that's going to be 5 to the 6th power. All right? I'm going to have you work on this next group of them. Oh, no, I'm making a huge mess here. Okay, here we go. I'm going to have you work on these. Remember, if you end, actually, I'll jump down to letter G here. If you have something like this one where when you add them together, you end with a negative value, then you're going to have to, whoopsies, that would be a -2. Then you would have to move it downstairs. Okay, so don't forget about those negative exponents when you work on this. So take a few minutes and try these problems out. Just jot them on a sheet of paper. And then when you're finished, unpause the video and we'll talk about the answers. Okay, hopefully you've had a chance to work through all these problems. And I want you to go ahead and pause the video again and check all of your answers. And then I just want to point out a couple of things. Okay, just a couple things I want to point out. This one right here, don't forget that when you don't see an exponent, there is a 1 that lives there. So that should be 4 to the 1 times 4 to the 5th. So your answer would really be 4 to the 6th when you're finished. And then just on H, make sure, because you had a negative exponent here, that you move it downstairs. That's just pretty much the product rule. That's all there is to it, that when you are multiplying the same base, you add the exponent. Cool. All right, let's move on. Let's talk about another one. Okay, so here is the quotient rule. All right, now anytime you hear the word quotient, it should make you think of division. So we talked about what to do when we're multiplying the same base. Now we're going to talk about what it looks like to divide the same base, okay? So this is going to look looks very similar to what we just did. We're not going to worry about standard form. And let me model for you what I would like for you to do. So the first one, 2 cubed. That means 3 factors of 2. That means 2 times 2 times 2 over 2 to the first is 2. All right, now if you remember your fraction rules, you are allowed to cancel factors, like the number of factors of 2 on the top with the number of factors of 2 on the bottom. They cancel each other out. All right, so all you're left is 2 factors of 2. So you have 2 squared. Okay, we'll come back to the rule form in a minute. Okay, so then the next one, you have 4 to the 5th, which is 5 factors of 4 in the numerator, and you have 2 factors of 4 in the denominator. And your fraction rules will tell you that you can cancel 2 factors of 4 on the top with 2 factors of 4 on the bottom, which would be 4 to the 3rd that's left on the top. All right, I'm going to just give you a hint before I turn you loose. When you get down here, we'll cancel your 2's with your 2's and your x's with your x's. This one here, the 2's just going to go along for the ride. So go ahead and pause the video, come back and check your work, see how much of this you get right. All right, hopefully you had a chance to check over or to do this work, and now you have a chance to check your answers. So go ahead and try to do that. I know there's lots of canceling out and lots of scribbles here, but go ahead and take time, go ahead and pause the video, check your answers. And now that you've done that, hopefully we can see what the pattern is. So every time we were dividing the same base, what we ended up doing was just subtracting the exponents. So for example, I had 4 to the 5th over 4 squared. Well, that left me with 4 cubed that didn't cancel out. Or when I had x to the 7, I had 7 factors of x, and I got to cancel 3 factors on the top with 3 factors on the bottom. So I was just left with the 4. Oh, I colored in too many. I'd just be left with the 4, okay? So what we're doing is we are subtracting the exponents. So like here I had 2 to the 3 minus 1, which gets me to 2 squared. Or I had 4 to the 5 minus 2, which gets me to 4 cubed. Or x to the 7 minus 3, which gives me x to the 4th. Down here I had 2 to the 3 minus 2 and x to the 5 minus 3. All right, so we were just subtracting the exponents when we were dividing, which should hopefully make a whole lot of sense. When we were multiplying the same base, so when we were multiplying the same base, okay, we added the exponents. Well, the opposite of multiplying is dividing, and the opposite of adding is subtracting. So if we add exponents when we're multiplying the same base, then it only makes sense that we would subtract exponents when we're dividing the same base. All right, so here is the actual definition for the quotient rule. So again, when you divide the same base, you subtract the exponents. Okay, so we're gonna do just a little bit of practice here. Let me kind of shrink this down. All right, so we're just gonna worry about the first 4 real fast. So I'll model the first one for you. 8 to the 5th, 8 to the 5th over 8 to the 3rd, you would just subtract the exponents, so that would be 8 squared. So pause the video and then check your answers when you're finished. Okay, so hopefully you had a chance to work on those problems. And now you're just checking your answers. So make sure on the bottom too, that when you end up with a negative answer, so when you do like 2 minus 6, that gives you negative 4, then you would move your x to the 4th downstairs. Because again, it's not considered simplified to have a negative exponent. Check this out too though. If I had written this out in expanded form, I would have had x squared on the top and x to the 6th on the bottom, like this. Well, the 2 factors on the top would have canceled with 2 factors on the bottom. Look, what are you left with? You're left with x to the 4th, and it's on the bottom. So that's another reason why these negative exponents work, right? That when I was subtracting those exponents, I ended with a negative 4, but it needs to go downstairs. That's because these extra factors of 4 are in the denominator. Same idea with letter D. You would have 1 over y cubed when you were finished. Okay, friends, I'm not going to lie to you now. Each rule by itself isn't that bad. What gets tricky with exponent rules is putting them all together. So we're going to attempt to do this in the section 4 piece right here. All right, so it doesn't actually matter which order you do these problems in. You are allowed to do them in whatever order you want. But the order in which I think is best is I would simplify your numerator, simplify your denominator. So like on this one, there's nothing to simplify. And then I would simplify top to bottom. Okay, so let me model that for you. And then I'm going to turn you loose to try the other ones, okay? And this gets a little complicated, so don't feel bad if you don't feel like an expert on this, okay? So on the top, I see that these 2 bases are the same base, are being multiplied together. So that means I would add the exponents. There's nothing to simplify in the denominator, so it's just going to go along for the ride. Okay, so then in the numerator, I have 3 to the 6th, and on the bottom, I have 3 to the 3rd. Well, when I have the same base being divided, I subtract the exponents. So I'm left with 3 to the power of 3. Okay, if you get stuck with things like that, use expanded form. Check this out, okay? I'm going to put this all in expanded form here. 3 to the 4th is 3 times 3 times 3 times 3. And then you had times 3 squared, which is 2 more, all over 3 cubed, which is 3 factors of 3. Well, what are you left with when you cancel out your factors top and bottom? You can cancel out 1, 2, 3 with 1, 2, 3. And what are you left with, my friends? You are left with 3 factors of 3, which is what our answer is. So those exponent rules allow us to take these shortcuts without having to write out all of these factors. So go ahead and pause the video, work on these on a piece of paper, and then unpause to check your answers. Okay, hopefully you've had a chance to do this work and you have checked your answers and they're all good. All right, so when we multiply the same base, we add the exponents. When we divide the same base, we subtract the exponents. We got one more rule to talk about today, guys. All right, last rule, guys. There's only one more, and it is the power to power rule. So what that means is that we have a power raised to another power. So this is the only rule left. And what makes this rule a little different, do you notice that we only have one base, but we have two exponents? So that's how I can kind of tell when I use the power rule versus when I use the product rule. So here's what happens. I'll model for you what we're going to put in the table here. So 2 cubed, I would write 2 cubed is 2 times 2 times 2. And then I have to have this 2 cubed 2 times. So now I'm going to write it a second time. So I have 2 cubed 2 times. Okay, the next one. I would have 3 to the 4th, which is 3 times 3 times 3 times 3 times that again. So I have 3 to the 4th times 3 to the 4th, which gives me 3 to the 8th. And I forgot to write this one up here, be 2 to the 6th. Again, we're going to skip standard form for today. All right, so I want you to pause the video, and I want you to work through these other ones, and we'll see if we can come up with the rule. All right, hopefully you've had a chance to look through those and check your answer, or now you're checking your answer. So go ahead and pause the video if you need to and check your answers. I want to just point out on this bottom one that you put your like things together. So I ended up with 6 factors of A in there. I ended up with 2 factors of B and 6 factors of C. And hopefully you realize that the rule this time is when we were raising something to a power, our powers to a power, we were multiplying the power. So this was 2 to the 3 times 2 would get us to 2 to the 6, and 3 to the 4 times 2, x to the 2 times 3, y to the 3 times 3, x to the 3rd times 1, and y to the 1 times 1. And this one was a to the 3 times 2, b to the 1 times 2, c to the 3 times 2. So the rule is, we'll write the definition on my next slide. So the rule is when you raise a power, which is an exponent, to another power or exponent, you multiply the powers together. All right. So go ahead and try these 4 down here and unpause the video, and we'll go over them together in just a minute. So pause first, you work through them, and then we'll talk about it. So this one we would have 5 to the 4 times 2, which is 5 to the 8th. This one we would have x to the 3 times negative 4, which is x to the negative 12th. So make sure you bring that downstairs because remember, we can't have a negative exponent. This one, tricky here. Don't forget that you have an exponent of 1 if you don't see anything there. So that should be 2 to the 1 times 5 and x to the 3 times 5. So 2 to the 5th, x to the 15th. And then lastly, we would have, another tricky one. Don't forget you have a 1 right there. So you'd have 3 to the 1 times 2, x to the negative 1 times 2, and y to the 2 times 2. So what does that give me? 3 squared, x to the negative 2, y to the 4th. But we're not allowed to have that negative exponent. So everything with a positive exponent stays up top. And then the x squared goes downstairs. Okay, friends. I would typically talk about each of these rules in a different class period. Like each day we talk about a different rule. So the fact that we're talking about 3 in one day is crazy. This is a lot. I just want you to try this. See what you can do with it. remember, the rules by themselves aren't so bad, right? When you multiply the same base, you add the exponents. When you divide the same base, you subtract the exponents. When you have a power raised to another power, all you're doing is multiplying. But it's putting it all together that can be really tricky. So what I want you to do is I want you to pause the video, and I want you to just try these 8 problems, actually 7, because you're not going to do this one. I just want you to try them on your own. And then unpause the video and check your answers and see how you did. It's not a big deal if you are not an expert at this. No, I don't want anybody to be stressed out about it. I just want you to try your best. All right, friends, let's see how you did. All right, here we go. I would add these exponents together first because they're inside the parentheses. So I'd have x to the 3 plus 1. And then that 2 comes along for the ride. So I had x to the 4th and then squared. And then that means I multiply the exponents when I have a power to a power. Okay, the next one, same idea. Add your exponents together first. So on the inside, you would have 3 to the 6th. And then that's raised to -1. When you have a power raised to another power, you multiply the powers. And then you're not allowed to have a negative exponent. So then that moves downstairs. How are you doing? Are you kind of getting it? Are you kind of close? All right, this one. This y to the 9th is out here all by himself. There's this -4 doesn't go to him. So I'm just going to let him come along for the ride for right now. So I'm going to have y to the 9th times, when I have a power raised to another power here, that's going to be y to the -12. And now I notice that I'm multiplying the same base, so I can add my exponents. And then I'm not allowed to have a negative exponent, so it's going to go downstairs. I mean, that's putting all of the rules together right there. If you got that right, you should give yourself a pat on the back. Like, solid job. And if you didn't get it right, that's okay. Do you get it now that we're going over it? So this one, I have a power to a power. So I'm going to multiply the powers. And then that's being multiplied by y to the -8. Well, again, I'm not allowed to have a negative exponent. So the positive exponent is going to stay up top. And the negative exponent is going to go downstairs. Let's try another one. Ooh, one's tricky because the x and the y doesn't have an exponent on it, so we have to remember that there's a 1 there. And we have a power. All these powers are raised to that outside of 3. So we would have x to the 3rd, y to the 3rd, z to the -12. You're not allowed to have a negative exponent, so x and y stay upstairs, and the z is going to go downstairs with a positive exponent. Okay, this one here is just like the top ones, all right? We've got the product rule inside here. So when you multiply the same base, you add your exponents. That would be 2 to the 5th. And then that's squared. And when you have a power raised to another power, you multiply your powers. So that's 2 to the 10th. And then this one, same idea. Don't forget that you have a 1 right there. You're going to add your exponents together because you're multiplying the same base. You would have 3 to the 3rd. And then that's raised to the -3rd. So then you would put your exponent up. And you're not allowed to have a negative exponent, so you move it downstairs. That was some pretty tough stuff, guys. We did a ton of work with exponents today. Nice job if you stuck through and tried these all on your own. And I look forward to seeing you soon.